Hello! In this video, we're going to derive the formula for the volume of a sphere. And we're going to start by drawing a circle. And let's say that our circle has radius capital R. Now, to derive the volume of a sphere, what we're going to do is we're going to integrate the volumes of a bunch of really thin disks from x equals negative r to x equals positive r. An example of what one of those thin disks looks like is something like this. So something like this. Now in 3D, this is what our disk looks like. And you can imagine a bunch of these thin disks all throughout our circle, ranging from x equals negative r to x equals positive r. But really, when you integrate the volumes of all of these thin disks from negative r to positive r, you really get the volume of a sphere with the same radius as our circle. To see why, well, you can actually see what that sphere would look like if you were to add up all of the volumes of these thin disks. And so, yeah, just like that, you would get the volume of a sphere with the same radius as our circle. And so, yeah, that's pretty much the idea. So really, to get the volume of the sphere, all we're doing is we're integrating the volumes of these disks. Okay, but what is the volume of our disk? Well, to get the volume of our disk, we're going to have to give it some constraints. Let's say that our disk is located at an x-coordinate x, and we'll say that the point at which the disk intersects our circle is at a y-coordinate y. So really, the coordinates of this point is x comma y. Okay, so now let's figure out the volume of this disk. Now really, our disk is a cylinder. If you recall, the volume of a cylinder is pi times the radius of the cylinder squared times the height of the cylinder. Okay, so as for the radius of our disk, that's really just the length of this line segment. In other words, it's just the y-coordinate of this point. So really, the radius of our disk is just y. And as for the height of our disk, that's really just the thickness of our disk. Really, it's just a small difference in x. In calculus terms, we write that as dx. So this right here is the volume of our disk. But I'm actually going to rewrite y squared in a different way. Because it turns out x, y, and r are all related to each other. The reason why is because the equation of this circle is x squared plus y squared equals r squared. And because x comma y is a point on the circle, it satisfies this equation. So if we take this equation and we algebraically solve for y squared, to do that, all we got to do is subtract x squared to the other side. And so we get y squared equals r squared minus x squared. So we can replace y squared with r squared minus x squared. So really what we get is this. So we can take our integral and rewrite dv disk as this. So now we have our integral with respect to x. But remember, we're integrating these thin disks from x equals negative r to x equals positive r. So really, our bounds of integration go from negative r to positive r. And now we're actually ready to evaluate this integral. So to start, because pi is a constant, we can pull that to the outside of the integral. And actually, we can evaluate this integral directly. So really, we just have the integral of r squared minus the integral of x squared. Now really, r squared is a constant. So the integral of r squared is just r squared x. And we're taking that and subtracting it by the integral of x squared. If you recall, by the reverse power rule, the integral of x squared is just 1/3 x cubed. And that's it. And our bounds of integration are negative r to r. So now, applying our bounds of integration, what we're going to do is we're going to take what we have here and replace x with r. And then we take that and subtract it by what we have here, but instead replacing x with negative r. And so now let's just simplify this up a little bit. We see that r squared times r is just r cubed. As for what we have here, r squared times negative r is just negative r cubed. And then after that we have minus 1/3 times negative r cubed. Overall, we know that this is just going to give us plus 1/3 r cubed. Next we have r cubed minus 1/3 r cubed, which is 2/3 r cubed. And then after that, as for what we have in this parentheses, we know that negative r cubed plus 1/3 r cubed is just negative 2/3 r cubed. And then we see we have 2/3 r cubed minus negative 2/3 r cubed. Well, the two negatives join forces to make a positive, and we're left with 4/3 r cubed. And this gives us 4/3 pi r cubed. And so this is the volume of our sphere. And yeah, that's pretty much one way in which you could derive the formula for the volume of a sphere. And yeah, that's pretty much it for this video.